Hello everyone, my name is Vivek Singh and today I am going to discuss the electric dipole. Let's begin. Electric dipole, as the name suggests, dipole, it means it has two poles. Fine. So whenever we have two equal and opposite charged particles separated by some finite distance, then it will make a dipole. Here we have a positive and negative charged particle and they are separated by some finite distance. Let's say the distance between them is 2L and the value of charge is this is minus q and this is plus q. So this makes the dipole. Fine. Now the strength of the dipole is calculated by a vector quantity that is called dipole moment. Let's see the dipole moment then. Dipole moment, and it tells us the strength of the dipole. Fine. It's a vector quantity and it is represented by letter P. The value and the magnitude of this dipole moment would be the charge multiplied by the distance between the two opposite charge particles. Fine. So let us say the Q is the charge here. Fine. Whenever the dipole is found, they will be found by equal and opposite charge particles. So the quantity, the amount of charge would be same, but they will be in opposite nature. Fine. So I am keeping Q as a charge particle and the distance between them is taken 2L. So this is the magnitude of dipole moment we have. Fine. It's a vector quantity, so it must have direction as well. So to find the direction of the dipole moment, it is always taken from negative to positive. So this is the direction of dipole moment we have. Now let's talk about the unit as well. So the SI unit of the dipole moment would be given by P is equals to 2 is a unitless quantity, it's a constant value. Q is measured in coulomb and the length is measured in meter. So coulomb meter is the SI unit of the dipole moment we have. Let's see some basic question based on the same concept which we have discussed now. Here we have the first question. Let us say that there are two charge particles Q1 which is equals to 2.5 into 10 raised to the power minus 7 coulomb, and the another charge particle Q2 which is equals to minus of 2.5 into 10 raised to the power minus 7 coulomb. These two charge particles are separated by some finite distance, then it will make a dipole. Let us see the coordinates of Q1 and Q2 is given. Coordinates of Q1 is given 0, 0 and plus 15 centimeter. Similarly, the coordinates of Q2 is also given, that is 0, 0 and minus 15 centimeter. Fine. Let's see the geometry, the location of these two charged particles. Let us assume along vertical I am taking Z axis. Here we have X axis and here we have Y axis. This is the origin we have. Now the location of the first charge Q1 is at 0, 0 and plus 15. Let us say the intervals are 5 centimeter, 10 centimeter and plus 15 centimeter. Here I am keeping the first charge, the positive one. The positive one is Q1. So I am keeping Q1 here. Now let's find out the location of the next charge, that is Q2, which is negatively charged. Fine. So I have to go downward, negative Z axis. Let's say this interval is minus 5, this is minus 10 and this is minus 15 centimeter. At this location I am keeping the next charge, that is Q2, which is negative charge. Now in this given situation, if we need to calculate the dipole moment, we must have the distance between the charge particle, fine, and the magnitude of the positive charge. Obviously the sum of these two charges must be 0 if we are making a dipole. Fine. Whenever we are making a dipole, the net charge on the dipole would be 0 because they are made by equal and opposite charge particles. Let's see. So the dipole moment is given by the value of charge multiplied by the distance d. Fine. QD. Fine. Here we can see that the distance between these two charged particles is 15 centimeter and 15 centimeter. So the total distance between Q1 and Q2 would be 30 centimeter. Fine. And the charge having value 2.5 into 10 raised to the power minus 7. So it would be 2.5 into 10 raised to the power minus 7 coulomb. And the distance is plus 15 and plus 15. The total would be 30. And it would be in centimeter. Let's convert this into meter. Fine. After converting, we'll be getting 2.5 into 10 raised to the power minus 7 multiplied by 0.3. Fine. We'll be getting 25 over 10 multiplied by 3 over 10 multiplied by 10 raised to the power minus 7. 75 over 100. So it would be 0.75 into 10 raised to the power minus 7, and the unit would be given by coulomb meter. Similarly, if you make it in standard form, we'll be getting 7.5 into 10 raised to the power minus 8 coulomb meter. This is the answer we have. Fine. The magnitude of dipole moment is equals to 7.5 into 10 raised to the power minus 8 coulomb meter. Let's talk about the direction as well. So the direction of dipole moment is from negative charge particle to positive charge particle. So the negative charge particle is Q2 and the positive one is Q1. Here we have Q2. So the dipole moment would be moving upward along the z-axis. This is the direction of dipole moment we have. The direction of P would be from negative z to positive z, and the magnitude is given by 7.5 into 10 raised to the power minus 8. This is the value we have. Fine. Let's see one more question. The question says that the system of charge particle or system of charge is situated at the vertices of equilateral triangle. This is the equilateral triangle we have, and the length of each side would be equal here. Fine. Let us consider the length of each side is a meter. This is A, this is A, and this is A. This vertices is A, B, and C. I am keeping 3 charge particles at the vertices. Let's see this. Here we have at point A, we have minus 2q charge. Minus 2q here. At point B, I am taking plus q charge, and at point C, I am taking plus q charge. I need to find out the total dipole moment of the system, magnitude of the total dipole moment of the system, and the direction of this total dipole moment of the system. Fine. First of all, if you observe this diagram, you will find that here we have minus 2q and here we have plus 2q. So how could we make the dipole here? For making the dipole, we must be having positive and negative charge in equal amount, and they must be separated by some finite distance. Now here we can clearly see that this one is plus q and this one is minus 2q. Here we have a plus q and here we have minus 2q. So for making dipole, what I can do is I can split this minus 2q into 2 parts. Minus q and minus q both are situated at point A. Now 1 minus q and this 1 plus q will make a dipole, and this 1 minus q and this 1 plus q will make a dipole. Let's decide the direction first. Let us suppose the charge at point B and the minus q charge at point A is making a dipole from negative to positive. So let's say this dipole is P1. P1 is dipole due to charge at B and charge at A. Fine. So the P1 would be directed from negative to positive. This would be the direction of P1 we have. Now if I am finding out the direction of the dipole moment due to one negative charge here and one positive charge here, let us consider that this dipole moment is P2. So the direction of This P2 would be from negative charge particle to positive charge particle. Fine. These are the two dipole moments we have. I need to find out the net dipole moment, the resultant one. Here we can see that the equilateral triangle makes angles 60 degrees of each. So here we have 60, here we have 60. Now the angle made between these two dipole moments would be 60 degrees. I need to find out the resultant. So for finding out the resultant, we will apply the vector method. Fine. So I need to find out the P net, the resultant dipole moment. It would be given by root under the vector law of addition is going to be applied here. So we will be getting P1 square plus P2 square plus 2P1 P2 cos theta, where theta is the angle between P1 and P2, which is 60 degrees. Let's find out the P1 and P2 first, then we'll put the value here, we'll get the answer. So P1 would be how much? It would be the charge, which is positive one, that is plus Q, and the distance between them, that is A. So QA would be the value of P1, and if you find out the P2, you'll be getting the same thing. P2 is equals to the positive charge in the dipole, and the distance between them is A. So we'll be getting QA here again. Now we do have the magnitude of P1 and P2. Just keeping this value in this expression, we will be getting net dipole moment. So square of P1 is equals to QA whole to the power 2 plus QA whole to the power 2 plus 2 into QA into QA into cos 60. Cos 60 would be half. Just simplify this. So after simplification, we will be getting this half and this 2 cancelled out. And the product of this QA and this QA becomes QA square. And this is square root, we will be getting QA square plus QA square plus QA square. Now if you will be adding them, we will be getting 3QA square root under 3QA whole to the power 2. Now we can take this QA whole to the power 2 out of this square root. So we will be getting the dipole moment, the net dipole moment is equals to QA root 3. This is the net dipole moment we have due to this system of charge. Fine. Let's find out the direction as well. So we know that the direction of the result passing through these two values are equal. So the net dipole moment this line, which is making 30, and which makes 30 degree from this P2 as well. So this is how the question would be solved. Now let's begin. Let's move to the next topic. Let's find out the electric field due to dipole along axial and equatorial position. Due to dipole along axial position. Let us assume we have some system of charge which is making dipole. Here we have minus q charge particle, here we have plus q charge particle, which is separated by some finite distance. Let's say the distance between them is 2L. This is 2L. And the line joining this negative charge and positive charge is called axial line. This is the axis of the dipole. Let's extend this axis. I am picking any random point along this axis and I will be finding the electric field due to this dipole. Let us say that this is the point P at which I need to find out the net electric field produced by this dipole. Here we have the origin. Let's consider this is the y-axis we have and this is the origin. This distance would be L and this distance would be also L. Fine, the distance between the origin and the charged particle would be L and L, and I am taking the distance of the point at which I need to find out the electric field is R here. Fine, let's discuss the direction of, or the quantity, the amount of magnetic field due to this positive and negative charge particle at point P. So here at point P we can see that the electric field produced by this plus Q charge would be rightward, because the electric field due to positive charge is going away from it. Fine. So if it is going away from it, let us consider that the plus Q charge is producing electric field is equals to E1, which is acting in right hand side direction. Now if I need to find out the electric field produced by this minus Q charge particle at point P, it would be directed towards leftward, because due to negative charge particle the electric field would be towards the charge. Fine. So electric field due to this negative charge particle would be towards, let's say this is E2. E2 is the electric field produced due to this negative charge particle, and E1 is the electric field produced due to this positive charge particle. Now you observe that E1 is little longer and E2 is little shorter. It means the magnitude, length of the electric field E1 would be larger than the electric field due to particle. Why so? The reason is simple. If you observe, you'll find that the point P is closer to this plus Q charge. So if it is closer to the plus Q charge, then the electric field at point P due to this plus Q charge would be stronger and it would be rightward. As the point P is farther away from the negative charge, then the electric field produced at point P due to negative charge would be smaller. It would have little weaker strength. That's why I made this E2 little smaller. Now at this point P, I need to find out the net electric field. Now the net electric field resultant would be given by E net is equals to E1 plus E2 in vector form. Fine. So for finding out the net electric field, I need to identify first E1 and then E2. Let's find out the magnitude of E1 and E2. So E1 would be given by 1 by 4 pi epsilon naught. If this dipole is kept in vacuum or in air, if it is another than this medium, let's suppose if there is medium which is not vacuum or air, so in that case the dielectric constant would be included here. Let's say constant K. Fine. Multiplied by Q over square of the distance between the point P and the charge particle which we are talking about. So E1 is the field created due to this plus Q charge. So this distance would be how much? The total distance is R. This distance is L. So if you subtract L minus this distance, fine. So the distance between the charge particle and the point P would be given by the total R minus L. R minus L whole raised to the power 2. This is the value of E1 we have. Let's find out the value of E2. So E2 would be given by 1 by 4 pi epsilon naught, the dielectric constant of the medium multiplied by Q, and the distance between this charge and this point P. So here this distance, the point P and the origin are situated at distance R, and this distance, the negative charge from the origin is given by L. So the total distance would be R plus L. Fine. So we'll be getting R plus L whole raised to the power 2. This is the value of E1 and E2 we have. Now if you subtract E2 from E1, we'll be getting the net electric field. Let's calculate the net electric field. So E net is equals to E1 minus E2. Let's put the value directly. So E1 1 not K, R minus L whole raised to the power 2. E2 is opposite, so I am taking negative sign here. 1 over 4 pi epsilon naught K Q over R plus to the power 2. Take some common, the values which is common here is q over 4 pi epsilon naught k. Fine. And here we are left with 1 over r minus l whole raised to the power 2 minus 1 over r plus l whole raised to the power 2. This can be simplified by liability. This is a minus b and this is a plus b. So after simplification we will be getting q over 4 pi epsilon naught k. The LCM would be r square minus l square whole raised to the power 2, and at numerator we will be getting square of this one minus square of this one. So square of this one would be r square plus l square plus 2rl minus of r square minus of l square and plus of 2rl. This is the final expression we are getting. Let's simplify this. So the thing which is getting cancelled out here is the negative r square and the positive r square. The negative l square and the positive l square is cancelled out. So finally we will be getting E net is equals to q over 4 pi epsilon naught k bracket close 2rl plus 2rl. So it would be 4rl divided by r square minus l square whole raised to the power 2. Now here we are making some assumption. The assumption is the length between the dipole is very small as compared to the distance between the origin and this point P. So this L, the distance between the origin and the charge L, is very smaller than the distance between the origin and the point P at which we are interested to find out the electric field. So this is the assumption we have. L is much smaller than R. So if L is much smaller than R, then the square of the length, the square of the L would be much more smaller. So we can ignore this value. So if I am ignoring this L square, how much will be getting? We'll be getting q over 4 pi epsilon naught k bracket close 4rl divided by, ignoring this L square, it becomes r to the power 2 whole to the power 2. So it becomes r to the power 4. Fine. Now this r to the power 4 and 1 are getting cancelled out. So this one and this one getting cancelled out. So after simplification we will be getting q over 4 pi epsilon naught k multiplied by, this is becoming 4l and this is becoming rq. Fine. Now this 4l can be written as 12 into 2. So 12 into q becomes the dipole moment. Let's see. So we'll be getting into 2 into q into l divided by 4 pi epsilon naught k rq. Fine. That this 2ql is equals to the dipole moment. So finally the expression is equals to 2 into E divided by 4 pi epsilon naught k rq. This is the value we are getting. Net electric field is this much. Fine. Now let's talk about the direction. So direction would be rightward. The net electric field is directed towards the right hand side. Fine. Let's see the vector form of this expression. So we are getting E net is equals to 2p over 4 pi epsilon naught k rq. This is the value we are getting. If you represent the expression in vector form, then here we can see that the net electric field is directed towards right hand side and the dipole moment is also having the same direction. It is from negative to positive. It means in vector form we can write vector E net is equals to 2p vector divided by 4 pi epsilon naught rq. This is the vectorial representation of electric field due to dipole along the axial rotation. Fine. If we are dealing with the medium like vacuum or air, so in that case the value of K would be 1. So in that case the equation would be simplified. E net is equals to 2p over 4 pi epsilon naught RQ. This is the formula we have for net electric field due to this dipole along the axial location. Fine. Let's begin with the electric field due to dipole along the equatorial location now. Equatorial position means the position which is perpendicular to the axial location. Electric field due to dipole along equatorial position. Let us consider there are one dipole made by two equal and opposite charge, minus q here and plus q here. Let me draw it here. This side. So here we have minus q and here we have plus q. Now these two charges are separated by some finite distance. Let's say the distance between these two charged particles is 2L. Let's say this is the axis, the line joining the charged particle, fine. And here we have the y-axis. This is the origin we have, and the distance between the charged particle is taken 2L here. Here we have the distance 2L. And the charged particles are separated by distance L from the origin. So this distance would be L, and the distance between the origin to the negative charged particle would be also L. Now I need to find out the electric field along this axis. Let us take some random point. Here we are taking random point P. At this point P, I need to find out the net electric field produced by this dipole system. Let us see the direction of electric field due to each of the individual charged particles. So from the positive charged particle, the electric field would be going away from each other. Fine. So the electric field would be emitted, and here we can see that the electric field due to this positive charge particle would be in this direction. Fine. Let us say that this electric field is taken E1. E1 is the electric field due to positive charge particle at point P. Fine. Now electric field produced by the negative charge particle is towards the charge itself. So it would be acting in this direction. Let's say this electric field is given by E2. Fine. Now it is very obvious that we are going to get the net resultant along the horizontal axis, negative x-axis, and the y component of the electric field is going to be cancelled out. Why it will be cancelled out? Because the distance between the point P and the negative charge Q would be equal to the positive charge and this point P. Fine. Let us assume that this angle is theta. So this angle would be also theta. Fine. This angle would be also theta. So this angle would be also theta. Fine. Let's break this electric field into the component. So it can be broken down into horizontal and vertical component. Here we have E1 is having component E1 cos theta, and E2 cos theta would be also directed in the same direction. Now in vertical plane, here we have E1 sin theta, and here we have E2 sin theta. If you see the magnitude of E1 and E2, you will be finding that the electric field is having same magnitude. So E1 sin theta and E2 sin theta would be cancelled out. Fine. The mod of E1 would be equals to the mod of E2, because the value of charge is same and the distance between them is also same. So these two electric fields, the sign component of these two electric fields are acting opposite to each other, so they are getting cancelled out. So I'm cancelling out them. So this is getting cancelled out. Fine. Now whatever the net electric field is produced due to this dipole is because of the cos component, the horizontal component of these two electric fields. Fine. Let's see the E net. So first of all, we need to find out the E1 and E2 first. So for finding out the E1 and E2, we must have this distance. So let us assume that the point P is situated at distance r from the origin. Fine. Now here we can see that there is a right angle triangle made. This is the right angle triangle we have, which has base as L and perpendicular as R. So this hypotenuse would be root under L square plus R square. Similarly, the same situation arises for the positive charge here. The base would be L here and the perpendicular is R here. So the hypotenuse would be root under L square plus R square. Fine. This is the distance between the charge particle we have and the point P. Now, so let us find out the value of E net then. So E net would be equals to E1 cos theta plus E2 cos theta. As E1 and E2 are the same in magnitude, fine, let us assume that this is equals to E. Fine. So I am keeping this value E cos theta and E cos theta, it becomes 2E cos theta. Replacing this E1 with E and E2 with E, will be getting 2E cos theta. This is the net electric field produced due to the dipole. Let's put the value of E here. So we'll be getting 2 into the value of E would be how much? The value of E would be given by 1 by 4 pi epsilon naught. If we are keeping the same whole system in the medium having dielectric constant K, then the expression becomes this much, where K is the dielectric constant of the medium, multiplied by the charge divided by the square of the distance between the charge. So square of the distance between the charges L square plus R square. So here we have L square plus R square multiplied by cos theta. Fine. For any of the triangle, if you find out the value of cos theta, the cos theta would be given by base upon hypotenuse. Now the base is L and the hypotenuse is root under L square plus R square. So it would be L over root under L square plus R square. This is the value of cos theta we have. Putting the value of cos theta here, cos theta is L upon root under L square plus R square. Simplifying this further, so we'll be getting 2q over 4 pi epsilon naught K multiplied by L over, this would be L square plus R square. Here we have power 1, here we have this root is having power half. So 1 plus half becomes 3 upon 2. Fine. Let's simplify this. Again we are making the same assumption. Fine. We are assuming that the distance between the point P and the origin is much larger than the distance between the charge particle and the origin. It means we are assuming that L is much smaller than the R. L is much smaller than R. If we are assuming this one, it means the square of L would be much more smaller, so we can ignore this value. Let's put the value here. So we'll be getting 2QL divided by 4 pi epsilon naught K. This would become 1 over, I'm ignoring this L square, so we'll be getting R to the power 2 whole to the power 3 over 2. Now this 2 and 2 getting cancelled out. This is cancelled out. So finally we'll be getting 2QL. Now this 2 equals to the dipole moment, where Q is the charge and 2L is the distance between these two charged particles. So I am replacing this 2QL with P. P over 4 pi epsilon naught K multiplied by 1 over r cube. This is the final expression we are getting. Net electric field equatorial position. Fine. And the final expression is E net is equals to P over 4 pi epsilon naught K multiplied by 1 over r cube. This is the net electric field we have. Fine. Let's talk about the direction. So here we can see that from negative to positive charge particle, the direction of dipole moment is along right hand, and the net electric field is directed towards the left hand side. So it means the electric field and the dipole moment is acting opposite to each other. In vector form, if you write the same expression, we'll be getting E net is equals to minus of P over 4 pi epsilon naught K 1 over r cube. Fine. This is the vectorial representation of the same formula. Now, the thing is, if you are keeping the same dipole in vacuum or in air, so in that case the K would become 1. Fine. So the formula remains same, only we have to replace this K with 1 only. So this is the whole equation we have for finding out the electric field along the equatorial position. Let's move to the another topic. Let us talk about the torque experienced by the dipole kept in uniform electric field. Torque on the dipole in uniform electric field. Let us suppose in this situation I am taking a uniform electric field. Here we have a uniform electric field. And in this uniform electric field, I am keeping a dipole having equal and opposite charge kept at some finite distance. Let's suppose here we have plus Q charge and here we have minus Q charge. Fine. Now the distance between them, let's suppose the distance between them is D. This is the distance between them, D. Fine. Now if you talk about the direction of dipole moment, the dipole moment is directed towards this direction from negative to positive. Let's say the dipole moment is represented by P and the distance between the charge particle is represented by B here. Fine. So this positive charge will experience some force whenever it is kept in electric field. Again, at the same time, this negative charge will also experience some force when it is kept in uniform electric field. So the force acting on positive charge when it is kept in electric field is given by F is equals to QE, where Q is the charge and E is the strength of electric field we have. Fine. Similarly, the direction of this force would be along the direction of electric field. So this would be the direction of this force. Fine. Now if we talk about this negative charge particle will be attracted by this somewhere there some positive charge particle, no? Due to the electric field lines are going in this direction. Fine. So this negative charge particle will also experience some force, but it would be experiencing force in just opposite direction. Fine. So here the force acting on this negative charge particle is given by F is equals to minus of QE. Fine. Now here we have two equal and opposite charge. Fine. But their line of action is not same. So in that case they will get a turning effect. Fine. It has some rotational effect. Fine. It means the dipole will experience some torque. Fine. Now we know that the torque is equals to force multiplied by force cross radius, force cross perpendicular distance. Here we can see that the force is given. Force is equals to F is equals to QE. Fine. I need to find out the perpendicular distance. Now if this distance is d, let us say the angle made by this dipole moment with electric field is theta. Fine. So if this distance is d, then this distance would be taken d cos theta, and the perpendicular distance would be taken d sin theta. This distance would be d sin theta. Fine. Now here we can see that this d sin theta is perpendicular to this force. Now this makes a torque. The torque is equals to force is QE multiplied by d sin theta. Fine. Now Q into D is basically the dipole moment we have. So I am replacing this Q into D with P. So we will be getting Q into D E sin theta. Let's replace this QD with P. So we will be getting PE sin theta. Fine. If you represent them in cross product of vector, fine, as the torque is a vector quantity. So if you represent the whole equation in the vector form, we will be getting tau, that is torque, is equals to P cross E. Fine. And the direction of torque can be found out by using right hand thumb rule. So this is how the torque on the dipole acting in uniform electric field is to be calculated. Fine. Let's call it off for today. Thank you so much.